All right, hello. This video we're going to be reviewing for the Chapter 6 Part 2 test, which is on arrays. And there's kind of, I guess, three things on here. There's binary linear search, and then there's array lists and 2D arrays, right? So this video we're going to just do a couple of review questions here. First one is I made an array list populated with strings called names. And you're just going to assume that I put at least 10 strings in there already. Pause the video and see if you can write out the command to do the following things. All right, so hopefully you've tried these already, and here are your answers. To get an element, you just call the name of the array, so names.get, and then the index you want to get to. Okay, and then normally, if you're getting it, you would store it. So I would do like string name equals that, and then I could say like hello to that name or insult them or whatever we want to do. We would store that, and since each one is a string, that would get the one at index 2. Technically be the third one in there because the indexes start at 0. All right, so to set an element, you're going to call the names.set, and you're going to specify the index first, so like 4, and then what you want to put there. Okay, so what this is going to do is overwrite whatever name is at position 4. Okay, so whatever's right there is going to overwrite it with Mac. It does return it, so if you wanted to do something with the name that got overwritten, you could store it. So I could do like string old name that was in there, right? And then this will wipe it out, right, with Mac and then store it here. All right, remove is very similar, right? We're going to call names.remove. Okay, and just specify the index. Again, it returns whatever was in there. So if you wanted to do the return type like I did number 2, you could store the result, but I'm not going to here. I'm just going to take it out. And then remember, the difference between set and remove is set keeps that spot and just puts Mac over top of it. When you remove, it actually makes the number of elements 1 less. So it'll shift all the other ones that are beyond 1, position 1, it'll shift them back 1 in the array list. To determine how many elements, you could do it. I'm going to just system out print, but then I would call names.size parenthesis. Okay, so if I print that out, that'll print out how many elements there are in there. And that's sort of normal, right? If you have like 5 friends in here, 5 names, then it's going to be a size of 5. Right? You just do names.size. Use .length for an array and .length with parenthesis for a string. Okay, so binary search. All right, so we haven't done this in a while, but we have a binary search method that takes in an int array of values, some data, and then a target value. Okay, and so we want to figure out what's going to happen if I call it with the target of 31 and then these values. Okay, so a couple of hints on this because this is kind of tough and we haven't done it in a long time. It returns the index of where we find this element. Okay, and generally like -1 if we don't find it. I think, yeah, return -1 if we don't find it there at the end. Okay, so basically we know the answer has to be, if I list some of these out, we're searching for 31, so it's going to return 5, 6, 5, 6, or 7, right? Because it is going to find it in one of those spots. But we have to go through the process of how it does it, the code, to figure out which one it does return. Okay, so I'd pause the video and give this a shot. I would make like a low, a high, and a mid index. I guess they call them start and end here. But I would track those variables and then kind of see what happens from there. So pause the video, give it a shot. Okay, so I'm gonna do, I guess they call it start, but we called it like low, high, and then we had a mid that it calculated because it always guesses the middle in binary search. So low starts off at 0, high starts off at this final index here, which would be 8, 1 less than the length. I'm going to put these on here. We've got low and high, and then mid is going to guess right in the middle. So mid is going to be, they calculate it right here, low plus high divided by 2, or start plus end divided by 2. So that's going to be 4. Okay, and then it's going to check to see, you know, basically if it equals, then we're going to return it. So that's the else, because basically checks, is the target less, is the target greater, and if it's neither one of those, then they're equal, and it's going to return that that index, right? But we're definitely not equal. Number 4, spot 4 is not our 31, that's 11. So basically we know our target is big. So you can dig through this code if you want, but realistically, if you just kind of remember how this works is all of these numbers aren't possibilities, right? Because we know it's bigger than 11, and since they're in order, all the ones lower than 11 can't count, and 11 itself. So what happens then is the low kind of jumps up here, and we recalculate mid. So if I go into my table, low is now going to be 5, high is still going to be 8, okay? And then when we do this recalculation right here of mid, right, now mid is going to be halfway between 8 and 5, so it's 13 divided by 2, which is 6.5, which is really just 6. Okay, so this is now going to become 6, right? So mid is going to jump right here, and then we're always checking spot and mid against the target. Okay, so at this point we actually are equal to our target, right? And so it's going to return mid, right? If you look here, right, if it's not less and it's not greater, then it must be equal. So we return mid, so we're going to return 6 right there. Okay, so if we dig down deep into this code and break it down, it's going to return 6, just on how it works. It could have potentially returned 5, 6, or 7, but the way the code works, it's going to return the index of the 31, which the one it's going to find is the one at index 6. So 6 is our return value. Okay, so that was a review of linear search, or sorry, binary search, where you guess the middle. Linear search, remember, is you guess one in a row. So you try to see if the target's at position 0, then position 1, position 2, all the way through, which is a lot slower than guessing the middle. But why would you ever want to use linear search? So that's the question here. Okay, and the answer is binary search is faster, but only works if the elements are in order. Okay, so if they're not in order, then you'd use linear search. If not in order, use linear search. That's the only time it ever really makes sense to do linear search. Otherwise, binary would be faster. And honestly, if they weren't in order, I would put them in order first and then use binary search. But that's another lesson later on. Okay, so creating a two-dimensional array. I just want to see if you can remember how to do the code for this. So the process of trying to recall is like the most important way to learn. So see if you can remember this, and then if you can't figure it out, you can unpause the video to see the solution. All right, so 7 rows and 2 columns. I'm going to do int, and then square bracket, because it's 2 dimensions, and give it a name like matrix or something. And then we're going to do equal to new int, and then I do the bracket thing. But the second time I specify the rows here, 7 rows and 2 columns. And so I put the 7 and 2 just like that when I do my call. Okay, and so that's how you create a matrix with 7 rows and 2 columns. All right, that's it. Thanks for watching.